So now we're taking our GCF process, greatest common factor, to the next level, where we go beyond just leading coefficient and variable, and we look for a whole term, perhaps in this case a binomial, that these have in common. Notice there is a 9x minus 1 on each side of the plus sign. So the plus sign is separating terms. Everything connected with multiplication is a term, and this 9x minus 1 to the 5th could be its own problem of multiplying it out, but that would be pretty terrible. Using the binomial expansion theorem, it would make it nicer, but we don't want to do that. We can just leave it here. Right now, we're trying to get more simplified rather than expanded. And so just like before, where we look for our coefficient part, GCF, and then we look for our variable GCF, the variable GCF part kind of transforms into a binomial GCF, where you kind of want to see this as if it was just a big X, and that this was like a big X. If that was the case, you would have said, oh, you have one X in common, and then how much in common is the lowest exponent? So you go, oh, it's actually the 4th. Well, instead of it being an X, it's just this 9x minus 1. So what we want to do there is say my common factor is the whole 9x minus 1. That's being raised to the 4th power because it's in common between the two terms, and the lowest variable, or lowest exponent, I meant to say, on both is the 4. So this is the most that they have in common. So 9x to the 4. So I'm going to factor that out. So I'm going to say equals 9x to the 4, 9x minus 1 to the 4th, times, and now we do the same work we had before with our greatest common factor. We divide each term by what we decided there was in common. So 9x minus 1 to the 4th. Now you treat this as if it was a variable. So the 9x minus 1 is a whole variable, essentially, because we're dividing here as if this was just an x to the 5th over x to the 4th. You would just subtract powers. And so there's just going to be one 9x minus 1 left over. So you put it in parentheses, 9x minus 1. There's only one of them left, to the 1st power, if you will. And then plus, I'm going to divide here by 9x minus 1 to the 4th power. This part is dividing by itself, and anything divided by itself is 1. So this whole thing turns into a 1. And then that plus 7 goes in the parentheses. So we say plus 7. Now, I could leave it like this. This is correct, but I am going to simplify it to make it cleaner. This parenthesis here doesn't actually matter. It was just grouping that this first term was the result of the division. So it really says inside there 9x minus 1 plus 7. So it would be beneficial to just go ahead and take my 7 and negative 1 and combine that to make 6. And so my final answer, the reduced form, will be 9x minus 1 to the 4th power times 9x plus 6. Now, there is some more factoring that we can do here. The 9 and the 6 have their own greatest common factor inside there. So after reducing, we want to take a look at what's left and see if we can go any further. And there is one step. The 9 and the 6 have a GCF of 3. So we can actually do one more layer by factoring out the 3. So off to the side, I'm going to say 9x plus 6. These both have a 3 in common. So if I was to divide this by 3, that would give me 3x. And then plus 6 divided by 3 would give me plus 2. So this 9x plus 6 can actually get replaced by 3 times 3x plus 2. So I'm going to go ahead and erase Actually, I'll write it off to the side. So this answer I had was complete with the binomial as GCF process, but we can simplify one step further if we were to factor completely, which is what the directions say. So this is 9x minus 1 to the fourth, and then you just put times 3 times 3x plus 2. And that would be factored completely. All right, in this second example, we've got just another binomial that's in common, and in this time, it's raised to the fourth power, just like the last one, actually. So I'm going to rewrite this to be 10x plus 7 to the fourth power, recognizing that they both had a 10x plus 7, and the lowest exponent is the 4. So that's the most that they have in common. So now I'm going to divide each term by 10x plus 7 to the fourth power. And when I do the first term, all that happens is these 4 reduce out from the 5 to have one 10x plus 7 left over. So I put 10x plus 7. And I found out in the last problem that the parentheses could be there, but they didn't benefit me. So I'm going to leave it by not putting the parentheses to group that term. And now I'm going to divide by 10x plus 7 to the fourth on the second term. And what happens is my terms reduce. That's a 1. Anything divided by itself is a 1. So then I have plus 5. So now I'm going to go ahead and combine these, the 7 and the 5. And I'm going to write it up top here. So I got 10x plus 7 to the fourth times 10x plus 12. And that would be complete with the binomial as GCF, but I'm supposed to factor completely. So let's make sure we take a second look at what we have written and see if there's any further factoring I can do. Well, looking inside here, I see a 10 and I see a 12. Those have a GCF of 2. So separate problem in the mix here, just factor out a 2. And factoring out a 2 divides each one by 2. And 10 divided by 2 is 5x plus 12 divided by 2 is 6. So I'm going to bring down my 10x plus 7 to the fourth power. And as long as everything's all squeezed together with parentheses and multiplication dots, what have you, we are completely factored. This blue box is the factored form. All right, now we're going to highlight a case where factoring by GCF is going to lead us to an error. But often students end up with an error here. When we have our GCF recognized as 9x minus 4, we see the lowest exponent present is 1. Well, here's what my students do. This is what not to do, so don't do this. What they do is they see 9x minus 4 as their GCF. So they write, all right, 9x minus 4, factor that out. And so our brain says, okay, I pulled it out. Well, that one's done. Okay. And then they just do this one, and they're like, all right, well, if I divide that one, if I pull one out, I'll have one less power. So they end up writing minus 9x minus 4. Just completely shooting past all the excellent notes we've taken of every time I've been dividing by my GCF, and we just totally miss it. When you factor out, it's not pulling out where I just pull it out and this is gone. It's got to be a division of 9x minus 4, your GCF. So let's try it again the right way. So it's not pull out, it's divide out. So again, recognize my GCF is 9x minus 4 to the first power, because that's the lowest power to win. And that's going to be equal to, you write it, your GCF, 9x minus 4. And then an open parentheses for the result of the quotient. So you divide by 9x minus 4. And when I divide anything by itself, it's not nothing, it's 1. So I put a 1 right there. That's what I was concerned about, is our brain says, oh, you pulled it out, it's nothing. No, you divided it out, it's 1. So then we take, this is a minus sign, so be careful to hang on to that. And then we got 9x minus 4. On the top, it's squared divided by 1. Any 1 just reduces 1 of the exponent up top. So I'm going to put minus parentheses 9x minus 4. So this time it was critical that I do end up putting the parentheses with that term because I need to distribute this negative sign across my 9x minus 4. So I'm going to have to double check that if I have anything that simplifies here. And so when I distribute, that's going to give me negative 9x and then plus 4. And that goes together with the 1 to make 5. And so I've got, I'm going to write it up here. Actually, I'll write it down below. 9x minus 4 times, and then it's 1 plus the 4 to get 5. So negative 9x plus 5. Now the problem says factor completely. It's a little bit of a ambiguous directive here when we're saying completely, because I would say this is done, but some textbooks want you to go ahead and pull out a negative because there's a negative in front of that leading term inside this one factor. So it's kind of open for interpretation, but we'll go ahead and factor the negative out also. I would say this is fine, but we can say 9x minus 4, and then there's a negative here, so you can make it a negative 1 that's getting pulled out, and then these just change signs to be a positive 9x minus 5. So I would say both answers are sufficient, but that'll work as well. And it's kind of ugly having that negative 1 in the middle. You could put it out in front, negative, and then 9x minus 4, and then times 9x minus 5. But kind of any of these last box things are looking good to me.